Use the graph to determine the domain and range of the function. The first question that we're asked to answer is, what is the domain of the function? So let's first of all recall, what is domain? Domain is the set of valid inputs. The set of valid inputs. So how do we determine the set of valid inputs from a graph? Well, the inputs are the values of x. So what I like to do is to imagine a vertical line. Remember, every function passes the vertical line test. So draw a vertical line and then move it horizontally across the graph from left to right and ask yourself whether each value of x is a valid input or not. Well, right now the vertical line is at x equals -10, and notice that the vertical line does not intersect the graph. Therefore, there is no output when the input is -10. -10 is not a valid input. If we slide the vertical line over to, let's say, -8, well, the vertical line at -8 doesn't intersect the graph either, so -8 is not a valid input. In order to find our first valid input, we need to slide the vertical line until it first intersects the graph of the function. And notice that the vertical line first intersects the function when x is equal to -3. So -3 is the first valid input. After that, -2 is a valid input, -1 is a valid input, 0 is a valid input, all the numbers between 0 and 1 are valid inputs, and we continue to get valid inputs until we reach the number 3. Once we go past 3, then the vertical line no longer intersects the graph and the numbers are no longer valid inputs. So the valid inputs range from -3 to +3. So I'm going to go ahead and illustrate here that our valid inputs start at -3 and end at +3. The input values are along the x-axis. Alright, so how do we write an inequality that represents those numbers? Well, we want the numbers that are between -3 and 3 and also including -3 and 3. So I'll indicate a solid point at the end. We do want to include -3 and 3 because the vertical line actually intersected the graph at those points. So -3 is the first valid input. +3 was the last valid input. And all the values of x had to be between those values. So we put the x in between the -3 and 3. The x has to be greater than or equal to -3 and less than or equal to +3. X must be between -3 and 3. All right, so what is the range of the function? Well, what we have to do is to recall, what is range? The range is the set of outputs. The set of outputs. So to find the set of outputs, use a similar procedure, but instead of using a vertical line, I create a horizontal line. And then I imagine sliding that horizontal line from the bottom to the top and determine whether the y numbers are outputs or not. Well, right now the y value of the horizontal line is -10, and the horizontal line does not intersect the graph. So -10 is not an output. If I slide the horizontal line up to -8, the horizontal line does not intersect the graph, so -8 is not an output. Continue sliding the horizontal line up until it first intersects the function. And we can see that it intersects when y is equal to 1. So 1 is the first output that we encounter. As we slide the graph up, we see that 2 is an output, 3 is an output, 4 is an output, but 5 is not. Only the numbers between 1 and 4 are outputs. So on the y-axis, we saw that 1 was our first output and 4 was our last output. We want to include both 1 and 4. So what we need to do is to write an inequality that represents these numbers that are between 1 and 4 inclusive. Well, 1 is the smallest value, 4 is the largest value, and the values of y are between 1 and 4. The y values have to be greater than or equal to 1, and they must also be less than or equal to 4. So y is between 1 and 4 inclusive is the range of the function.